Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 5.3, Problem 10. This is Section 5.3, Problem 10, and it says the grand prize for the TV show America's Got Talent is $1 million. Now, most people are familiar with that, but the thing is, the winner does not get the $1 million all at once. It's paid $25,000 per year over a period of 40 years. So after taxes, it'll be even less. You have to pay taxes on the $25,000 that you get per year. So how much does the producer of the show have to invest now at 8% compounded annually to pay the winner? So this is a present value of an annuity question. You're investing some money up front to pay a salary, and the interest that you earn on the money helps pay the salary. So the formula for the present value of an annuity is A, that lump sum, equals P, the regular payment, times some pretty big brackets. In the numerator of the brackets, you have 1 minus 1 over, in parentheses, 1 plus r over m, close the parentheses, to the exponent m times t. And in the denominator of the brackets, you have r over m. So now we fill that in. And we have A equals P, the regular payment for this question is $25,000 every year. So I'm going to have 25,000 times those big brackets. And to fill in the brackets, on the numerator of the brackets, I have 1 minus 1 over, in parentheses, 1 plus r over m. Now the value of r is the rate as a decimal. So the rate for this problem is 8%. As a decimal, 8% is 0.08 over m. M is the number of times compounded per year. This problem is compounded annually, and also the payment is made annually once. So m is 1. So I close the parentheses. The exponent on the parentheses is m times t. Again, m is 1 for the annual compounding. The t is 40 because that gets paid out over 40 years. The $25,000 each year times 40 years comes out to a total of $1 million. And then in the denominator of the brackets, we have r over m again. So the r, the rate as a decimal, is 0.08. And the m, the type of compounding, is 1. It's annual compounding. And this is what I have to figure out. Now, as with all these problems, there's some parentheses as part of it. I need to do the work in the parentheses first. That's the rule for math. So I will have A equals 25,000 times, in some brackets, 1 minus 1 over, in parentheses, the 1 plus r over m. The r over m, 0.08 over 1, is just simply 0.08. And I have to add a plus 1 to that, so 0.08 plus 1 would be 1.08. Close my parentheses. There'll be an exponent on the parentheses. The exponent is 1 times 40, which is just 40. The 1s make it fairly easy to deal with the annual compounding. The denominator of the brackets have r over m again, 0.08 over 1, which divides out easily enough, 0.08. So now I'm going to have to use my calculator. The next thing I need to do is the 1.08 to the 40th power, which is not something I think anybody can do without a calculator. So that's going to make A equals 25,000 times some brackets. And in the numerator of the brackets, you'll have 1 minus 1 over the result of 1.08 to the 40th power, which the calculator will tell me is 21.7245215. And in the denominator of the brackets, I still have my 0.08. So in the numerator of the brackets, I have 1 minus a fraction. I want to reduce the fraction. It's 1 minus 1 over 21.7245215. Let me divide that out. Again, you can divide the whole thing out by re-entering all those digits, or you can just press the 1 over x key on your calculator when the 21.7245215 is on the screen. That's how I'm going to do it. So however you do it, once you complete the division, the numerator of your brackets will have 1 minus 0.0460300933, and the denominator of the brackets would have 0.08. So in the numerator of the brackets, I have to do the subtraction 1 minus 0.0460300933. So that gives me a next version of my formula. A equals, don't forget this, still times 25,000 out in front of the brackets. And in the brackets, in the numerator, after you do that subtraction, you get 0.953969066, and in the denominator of the brackets, you still have 0.08. So let me divide out the top and bottom of the brackets. I'm going to divide 0.953969066 divided by 0.08. So that's going to mean I will wind up with 25,000 times, in the brackets, there'll be one value, and it will be 11.9246133. So to finish the problem off, I have to do the 25,000 in front of the brackets times the 11.9246133 that's inside the brackets. And the calculator will do that almost instantaneously for me. Put those numbers in, multiply them, hit equals, and the answer is A equals 298,115.3333. Now again, for my final answer, I don't want to have more than 2 places after the decimal. I have 4 right now. So the 0.333, the third 3 out, isn't big enough to make it 34 cents. So my final answer will be $298,115.33. So with a little under $300,000, they'll be able to pay the winner for the season $1 million. But that takes 40 years, and the rest of the money between the almost 300,000 and the 1 million comes from the interest that the $298,115.33 earns over that 40-year period. Even though you're taking out 25,000 a year, it's still going to make a lot of interest in 40 years.